Good afternoon and welcome to the fourth in our series of first semester pracs for PhiLab 1. In this prac you'll be using all the things that you've been taught to date in the first three pracs, and you'll be extending that knowledge first of all by linearizing data, and secondly by using the equations that you'll find in the guide to do a least squares fit. So you'll use these data and calculate a least squares fit. As always, we start off by gathering some data. Now, the apparatus you're going to be using is quite straightforward. What we have here is a timer, a mechanism that can hold a ball and a release mechanism in it, and a sensor that measures when the ball has hit the thing. We'll start off by adjusting the height of this release mechanism and then measuring that height by means of a meter stick like this. You'll fit one of these little steel balls into the release mechanism, then you will reset and set the timer, and the reading that you'll get there you'll record in a data table like this. Now, having gathered 10 sets of these data pairs, you're going to linearize these data in a way that you will see in the guide as well as the instruction manual. The next important step in the process is that we want to find some mathematical representation that will fit these data. And what we've got to do is we've got to confirm that what we want to do is in fact valid. And the way that we do that is by this graph. We're going to use these data to plot the graph of h over t versus t, and you should get something like this. Having satisfied ourselves that these data are in fact suited to being represented by a straight line graph like that, we're going to use these data to calculate the coefficients, the gradient and the intercept by means of a least squares fit. Now, these equations you'll find in the guide, and we're going to use that in two ways. The first way we're going to do it is by using Excel. And the second way in which we're going to do this is by using a program which you'll find on the computers in the laboratory, Linear Fit. You will find that both of these methods give us the gradient and the intercept along with their uncertainty. And remember that this is a type A evaluation of uncertainty. And the reason for that is because the uncertainty here depends on the scatter in these data. Consider also that those two results using the two different calculations come from the same original set of data. So we expect to see that these results are the same, but it's a requirement that you do a comparison in any event. The final step in the process, of course, is to use this coefficient to calculate G, which you'll see is quite a straightforward business, as well as the uncertainty in the result of G. Some important points in the prac. You need to do comparison. In other words, you compare the result of G that you're going to get here with the result of G that was given to you. Compare these two sets of results that you're going to get over here. And then finally, we'd like you also to comment on the value of the intercept. What does the intercept actually represent in this real world situation? And lastly, don't forget to include an uncertainty budget. Thank you.